Welcome to another video from explainingcomputers.com and to my first tutorial on Raspberry Pi robotics. Specifically, in this introduction, I'm going to show you how to write simple Python scripts, how to connect LEDs to the Pi's general purpose input-output pins, and how to use Python programming to turn them on and off. To undertake this tutorial, you're going to need a Raspberry Pi. Here I've got mine in the same case I installed it in my previous Raspberry Pi videos. You're also going to need a USB power supply to power the thing, and you're going to need an SD card installed with the latest version of Raspbian, again as I showed you in my first Raspberry Pi video. You're also going to need some LEDs, and here I'm going to use three standard 5mm LEDs. And to stop us blowing up the Raspberry Pi when we connect LEDs, you're also going to need some resistors. Here I'm going to use two 70 ohm resistors to protect my Raspberry Pi from when I connect the LEDs. Tiny little things, as you can see, but difficult to handle. You can tell it's a 270 ohm resistor because the color code starting from the left will be red, violet, brown. Finally, to link things together, you're going to need four jumper leads, here with a female connector on one end to connect to the Pi and a male connector at the other, or here though it's just actually a bare wire. These are not proper jumper leads. I scavenged these from inside a computer audio cable. And I'm also going to use a breadboard, which is a neat way of just linking together different bits of electronics. You don't need to use a breadboard. You could solder things, you could even twist wires if you really wanted to. But this breadboard, as you'll see, is rather yellowed, which indicates it's about 35 years old since I first got that breadboard, which perhaps suggests that once you've got a breadboard, it's going to be a rather useful device. But before we start plugging things together, I think I really need to show you a little bit about how you create Python code on your Raspberry Pi. Okay, here we are on the Raspberry Pi Raspbian desktop. I'm going to show you how to write a bit of Python code using the Interactive Development Environment, or IDLE. So I'll run up IDLE. While that's running up, I would just stress this is exactly the same desktop you'll get in Raspbian if you've just installed it. I've just made a few changes to things like font sizes so you can see things a bit better on the screen. So we're now inside IDLE, which is interactive because you can actually type Python commands directly here and run them. So I could type, for example, print hello, press enter, and it would print hello, which is not terribly useful but proves a point. We want to write a longer piece of code. We have to put a new window in. Here we are, and we could now write something like, for example, put say a little loop in for x in range 0, 3. This will actually increase the value of x up to 3. And we'll put a colon in there, and when we press enter it'll indent the next line because this bit of code will run inside the loop. And we could put, for example, print, I don't know, motor on, and say print motor off. Let's imagine those commands were controlling a motor. They aren't, but that's the robotics principle we're going towards. We now need to save our piece of code, so we'll save that. I will save it in my Python code directory, and we'll call it, say, motor print test. Save that. And we can now run this piece of code. If we go to run module, and you can just press F5 to do this, and you will see it will print motor on, motor off, motor on, motor off 3 times running that piece of code. So we close that down. Go back to our program. Now that's all very well, but you might want some control of a motor if that was a motor. You might want to control how long it was on for. So what I'm going to do is to import what's called a library. A bit of Python code isn't always available. You have to tell the computer you want it. So I'm going to type import time, which is a set of commands which, surprisingly enough, allow us to use some time commands. So after we've had our motor on, I'm going to say time.sleep 1, which means sleep or wait for a 1 second value. And after we've had the motor off, we'll also do a time.sleep 1, save our program again, file and save. And if I now run the program, I'll press F5 this time, it's going to now motor on, wait, motor off, motor on, motor off, motor on, and motor off, because it's been waiting for those time commands. So that's a very, very brief introduction to a little bit of Python coding, showing you how we can actually create a loop and showing you how we can use the time command. Right, now you know a bit about how the code's going to work, we can turn our attention to hardware. So I'll go to our Raspberry Pi, and the first thing I'm going to do, as you can see, is to remove the top cover, just so we've got proper access to the GPIO pins. Make sure you take the screws out properly. I'm then going to take the Raspberry Pi, and with some Blu Tack added, I'm going to secure it to a piece of plastic. We have also already secured, as you can see, the breadboard. You don't have to tie things down like this, but it will hopefully just make things a bit easier to get on with the wiring, move this thing around, and also to show you on camera. So what we're going to do here is to create a circuit between the Pi and one of our LEDs initially. So to set that up, we'll connect our first jumper lead to pin 7 on the Pi, and then we'll connect that lead to one of the first rails on the breadboard. In case you've not used a breadboard before, the basic principle is that we have rows of connections here which are all linked together. So all these connections across are linked, and then down the edges we have 2 rails which are also linked. So electrically this allows us to link multiple things together. So we'll take our LED. This is the LED, and you'll see it's got 2 different lengths of pin, a longer pin and a shorter pin. The longer pin is positive, so the longer pin will connect into the same rail as we've just connected to the Pi. So effectively we've connected that straight through. We're now going to take one of our resistors, which I've actually bent around a bit so we can fix it to the breadboard, and that's going to be connected in like so. If I just put it in first, we can get the thing in. There you are. And what that effectively does is to connect the negative terminal from the LED through to our ground rail on this board. Finally, therefore, to make this LED work, we need to connect pin 6 on the Pi with our negative rail connector, and that's going to go through to be linked to the negative rail on the breadboard. It can, I think, be a little difficult to see exactly what's going on here on the board, so here is a diagram which shows you exactly how we've connected pin 7 on the Pi through to the LED to its long terminal, linked it through to the resistor on its short terminal, and connected that terminal back to pin 6 on the Pi, which is its ground or negative connection. Because I want to show you how to program 3 LEDs, much more exciting than just one, I'm now going to repeat this stage and add in a second LED connected through from pin 11 on the Pi, and then pin 13 on the Pi, again connected through to a positive terminal LED, back through a resistor back to the negative rail. And here you can see the setup, which is all ready for us to start trying out some programming. Okay, here we are back on the Raspberry desktop, and I'm now going to write a bit of Python code to control our LEDs. I've got a camera there on the Pi, as you can see, so you can see what will be going on. It's not quite as bright a shot as we normally have, but that's set so we can see the LEDs light up hopefully in a minute. Now this time we're going to use idle again, but I can't run idle here from the icon. I'm actually going to run it from the terminal. So I'll run up LX terminal. I'm going to type sudo idle. And here sudo stands for super user do. So this will run the idle environment as a super user, or what's called in root mode. It's very important you run idle in root mode as a super user when you want to control the general purpose input-output pins on the Pi, because if you don't, it won't work. So I'm going to load in our recent program called motor test. There it is, look, and I'm going to alter it a little bit so we can control the general purpose input-output pins and control our LEDs. First thing I'm going to do is to import the library that allows us to control those pins, which is our pi.gpio as GPIO. So that command will load in the general purpose input-output pin control library. Now it's important to state that this library was only included by default in Raspberry and on the Raspberry Pi fairly recently. So if you've installed Raspberry from, for example, the noob setup I showed you on my first Raspberry Pi video, if you've installed it before about Aprilish 2014, you might not have this library on your machine. So the best thing to do before you start experimenting with this stuff is to install the latest version of Noobs, install Raspberry, and you'll be sure you've got this command available. Right, with our libraries installed, that was a bit heavy, wasn't it? But you need to do it. First of all, we're going to do a few setup things. So I'm going to type GPIO.setMode, and I'm going to type GPIO.board. What's that all about, you cry? Well, this command tells the Raspberry Pi the numbering system we're using for the pins we're going to talk about. If I bring up a picture of the pins here, there's various ways you could number them. The board numbering system which we're using here is the simplest one, which means the pins are numbered 1, 2, 3, 4, 5, 6 across, as you can see there. There are other numbering systems that are more complex to use, so we'll use the simple one, which is board. Next thing I'm going to do is to set up a particular pin as an output. So go GPIO.setup, and I'm going to go 7, GPIO.out. What that command is doing is telling the Raspberry Pi to use pin 7 as an output. And there are 8 different pins you can use to do that with, as you can see on the diagram here. But here we just need initially pin 7. We'll then go back down into our little loop. In our loop we were there printing motor on, but here I'm going to control the LED by typing GPIO.output, and I'm going to go 7, true, which will turn on pin 7 and hopefully light up our LED. We'll then go down here and we'll turn motor off to GPIO.output. You can probably guess this bit, 7, false. That will actually, of course, turn off the LED. And finally, down here, I'm going to type GPIO.cleanup and opening and closing brackets. What that final bit of code does is it sets the GPIO pins back to neutral after this piece of code is run. That is irrelevant for the first time you run the piece of code, but if it isn't there the next time you run a piece of code, you'll start to see error messages. They won't stop things happening, but it'll make things look terribly problematic, and so it's better to be tidy. So there's our piece of code. It loads in to libraries. It sets the board up in board numbering mode and sets pin 7 as an output, and then it runs a little loop which should turn our LED on and off 3 times. So I'm going to save that as a new program. We'll call it blink 3 because it should blink the LED 3 times, and we will then run the piece of code, make sure we can see there the actual board, and if we run the module, yes, everything's wired properly. The LED is going to blink 3 times. Isn't that amazing? It certainly is. But of course we've got here 3 LEDs, so what I'm going to do is to load in a piece of code I wrote earlier, if I can get the menu in the right place, and it's going to be running light 7. You can probably guess what this does. Similar piece of code, again loads in the same libraries we've just seen, again sets up the board numbering. Here then we're setting up 3 pins, 7, 11 and 13 as our outputs. We're going to run a loop with 7 parts to it. We're then going to turn on pin 7, wait half a second, turn off pin 7, turn on pin 11, wait half a second, turn on pin 11, turn off pin 11, turn on 13, wait half a second, turn off pin 13, and clean things up at the end of the loop. And if I run that piece of code, run module, you will see, hopefully by magic, there we are, look, we've got a running light turning on 3 LEDs in a nice little sequence, which will run 7 times. Is that amazing? Well, you might think I've seen a flashing LED before. It's not very amazing. Or you might be thinking we have proved how we can use a piece of code to actually control an external electronic device linked to a computer. And that, I would suggest, is a really fundamental thing to have learned how to do. In this video, we've started to see how a Raspberry Pi can interface with external electronics. In the next video, I'll take the techniques we've learned and apply them to control a motorised robot. But now that's it for another video, and I hope to talk to you again very soon.